Let's start to figure out how I'm going to machine these parts. Hey guys, welcome back to episode 4392 of this series. Well, it feels like that anyways, but yeah, so some of the, actually most of the equipment showed up for the machine. So the fourth axis rotary showed up, a lot of the fifth axis fixturing and all that showed up, but none of that comes with hardware. So I had to order some heavy bolts and T-slot nuts and things like that to get everything configured on the machine properly before I can start cutting material. And that's okay because, well, I still am trying to figure out the software aspect of it. So I've been tinkering with that a little bit here over the weekend and the evenings, but haven't come up with anything super solid and concrete. You can see I've tried a couple different configurations here. Let's see, I'll get some of these to open up for you to see what different thought processes I had run through my brain. And here it comes. Big files, so they take a second. Come on. There we go. All right, so this was, actually that's the latest one. I want to say this was my first idea here, so I'll just open them all up and, oh, the computer yelled at me. I'm asking too much of it at once. So, um, all right. Come on, here we go. All right, so this is kind of what the machine's going to look like when it's all set up, but you can kind of see what my first idea was to set this up was in a flatter fashion here. This rotary here turns along this x-axis line, so this whole block here rotates in a circle, and it can stop at any angle that I need it to machine a specific face or hole or anything like that. Now, ultimately, the axis or the rotary table's turning at the same time the tools are cutting, and you get full three-dimensional reach around all kinds of things. The only face you can't cut on this is you can cut this face out here flat or contour it with what they call an undercutting or a lollipop type tool, but you can't drill from this side, tap holes from this side, thread from this side or whatever. That would need a 5-axis machine. But anyways, if in setting it up like this, if you can visualize as the tools come down from the top, I can cut all the surfaces. And let me close out that stock so you, oh, I can't close that out here. So, oh, there it is. It's off now. So you can see what I'd have access from the top. As this was to rotate, I could come down straight down here, drill these holes, cut these angles, put the threads on. I could stop. Really not using it as a rotary axis. I would be using it as what they refer to as an indexer. So I would be indexing the part to different angles for to access different features and machine different parts. So that I can come to this area, drill and bore this tool. I was looking at it from this side. I would need a really long tool to, I gotta turn off some other, oops, let's see. go. Now we can look at it from this side here. Okay, so now here's our part. So if I, let's see if I can get this to rotate the way I want it to. It's not gonna, oh, wrong button. Okay, I can't get to the 45 on this, but I can finagle it around in three-dimensional space. And, all right, now you can kind of have this almost flat vertical. So if I wanted to do this, the tool holder would have to be up here. It'd have to be a really long, narrow tool to not hit this fixture. Not to mention if there's a part in that fixture, I really don't get a lot of access to that. But that's not that big of a deal. But I figured there had to be a better way, so I just I decided to approach the task a little differently. So I'm not going to save that because I didn't alter anything. Okay, so then I want to say I did. Let me just look at this one. This might have been my next adventure down that road. I mean, this is kind of pointless because I'm showing you where I eventually ended up first, but I want you guys to understand the different methods to approach this. Okay, so this is a different configuration. So instead of clamping from the top of the part, I'd actually clamp from the bottom, which means I can't access any of these threads, the hole up the bottom, the taper, any of that. But I can get an awful lot of everything else to some degree. So that seemed to be the next logical guess. And I played with it a while. And then I decided that that wasn't what I wanted to do. So then I wanted to approach it completely differently. And bear with me, I got sun in my eye. But okay, so then the next approach that I took was thinking, I want the last operation. So when the part comes off of this fixture, I want to have minimal operations, minimal secondary operations. So it kind of makes sense to position the part like this. So I could essentially cut almost everything on this except for this cylindrical part here that I'm highlighting and the front face. I could even bore the RCA hole all the way through, and then all I would need to do is flip this piece when it comes off of this machine over into a custom fixture that would hold it flipped from the 180 degrees from the system it is now. If I bored the hole down through, I could theoretically indicate it with that hole, and then I could cut this column, this radius on here, flatten the surface, and that's done. That would be, under a minute operation, actually, maybe a couple minutes tops if I was being conservative. So this seemed like a very, very doable operation, but I decided to go a different way, as you've already seen. Let me see here. I gotta show you where we'll give you an idea what the machine tool does. Here, I just did some basic operations. This wouldn't be a complete part, but you can kind of see how the tool would come in and approach this. And I don't know why the CAM simulation software does this, but the tool would always be coming down from an upper position in the machine tool that I have, and the fixtures would be rotating to get the proper angles for the the part, but all the simulation software I've ever dealt with holds the part stationary, and it appears that the tool's revolving and moving around that, but that's not the case. The tool's stationary other than going up and down, and then the parts move left, right, front, back, rotate, things like that around it. So um, this, as you can see, gets pretty darn close to a finished product. Although if you look from the left side here, you can see I can't really reach that. The tool's colliding with the features here, and I could stop not cutting all the way down here to the base, but that would leave an awful lot of what they call secondary operations, which is not the end of the world. It's really not that hard, but you need to make sure your fixtures and your secondary operations allow you to indicate within a really fine accuracy the part that comes off the first operation. So, all right, I think that is about done simulating. Last few passes now, and in fact, those passes are actually unnecessary. I could have stopped that from going so deep, but anyways, I was just playing around to get an idea here. So you can kind of see, obviously, you can't cut away the base that holds it to the clamp, or it's just going to fall. So there's a lot of fine tuning. I'm just now trying to get comfortable with the features of the software, and then I will work within the limitations of the angles of approach and access that I have. So, but you can see, you just saw it take a solid block and machine it from the various angles, and it come up with a basic casing. It pretty much hollowed out the motor cavity. It's not perfect. I'd have to go in with a much smaller tool to get the tiny details, but it has bored the RCA cavity from the inside, the motor cavity, and I have drilled the hole for the tube stop, and generally rough cut the taper, which you can see is kind of like a like bleacher seating, like stair stepped all the way up, because that's just a rough cut. I actually have a physically like an angled 7-degree angle tool that goes in and just works as a chamfer, a 7-degree chamfer, to smooth that all out. So I mean, this is all mostly just rough cutting. I did kind of do a finish cut to see what kind of step overs and step downs I wanted to use for finished appearance, and I may get it even finer than that before we're done. I'll play with different settings, and those will dictate how much either hand finishing, polishing, or tumble finishing, like a mass vibratory tumbler that we have. We throw all the parts in there with ceramic media, and then just let it shake, and it's pretty cool. A lot of fun. Unfortunately, sometimes the small pieces get stuck in compartments that are a pain to get out, but that's why you want to minimize that stuff. Get as close to a finished product with a machine. So, but you can get the general idea on how the machining process works. There's probably 8 or 10 more operations that need to be added to this to get a final product. You'd have to drill and tap the holes for the faceplate on it, come in with a finer tools and do remove most of this rough stuff. It leaves a few thousandths of material over the whole surface. You remove as much material as fast as you can without much accuracy. So you leave a layer of error there. And then you come in with a finer, more accurate tool, and that's when you do your finishing passes. So the whole thing would pretty much need finishing passes. Cut the threads, finish the taper, drill and tap the holes, and that's kind of about it, but it takes a number of operations to do that from different angles. So that's where that is. And And then I avoided this because I can't really access the 3D contours properly um, from this angle without having real collision problems here. Now I could build another fixture that extends out and only holds one part at a time, and that would allow me closer to full circumference access to the part, or I could hold it from, if I wanted to do one part at a time, I would actually hold the clamping force from the end of the rotary axis, and that would allow me full 360-degree access around the part, but there's some limitations on that too. And the idea is to make more products with less handling. So um, if I'm even if I can't come off with complete products in these 4 operations, if I can get 4 operations 90% complete, that means the machine's running somewhat unattended uh, for a longer period of time than somebody standing there and every, say, 20 minutes, 15 minutes popping in a new part and coming off with a close to finished product. So time is money. We all know that. Man hours are money. So anyway, so let's get out of that because we're not using it. And then in the long run, this is the method that I decided to go with. No, that's not it. Ha! I lied. All right. I inversed this. So where? Okay. So I looked at this one. Um, second operation. I can get all the way around this, all the way down, other than the threads. The hold and taper drilled up from the bottom. That's actually a realistic approach, but I think that let me close out of that one. Okay, here's the final one. Yes, this is what I decided to do, or at least at this point in time. All plans change. You can see I'm putting the machine body held from the top upside down, and now this will allow me. Okay, I can't machine from this side, so let's show you the faces I'm going to physically machine from. I'm going to machine from this face here, which allows me to get all the way down on the sides. I can 3D contour this all the way from this side. I can bore out the machine cavity. I can rotate the part this direction to do the RCA cavity. I can rotate the part this way to some degree with a really long tool and cut this pocket out. That is for the top of the needle bar. It has to have a little bit of side-to-side motion. I can come from this end, bore all the way down through, cut my taper, do my threads, everything like that. I can come to the back side. I can very delicately cut out the full 3D contour around the RCA jack, all that other fun stuff. Obviously, I can't cut between the clamp and the part. Well, I can, but there's some fun stuff that's going to be done for that. And basically, what ends up happening is I'm going to finish this part almost entirely, and I'm going to leave what they call tabs. Now, and then the tabs are the last part you need to remove from the product in your second operation. So that means nothing important would be done in the second operation. I wouldn't be cutting threads that need to be perfectly aligned with something else, or I wouldn't be, nothing would be critical. It would physically be just removing tabs, and I can do that with just a simple fixture, an indicating probe, and then just a flat end mill to machine them off. So quite often people do tabs, so you get a solid product, and then they'll leave just a single tab of a certain thickness. So they'll do all the machine work, heavy work on the product, so everything critical is done, and then they'll work their way back towards the tab for the outside profile. So you're leaving as much material holding the part on as possible till the last possible second. And then you slowly machine it down so that tab gets thinner and thinner and thinner and thinner to where the part will actually kind of spring a little bit. And and then you can physically grab it and just twist it off the machine, and then you just physically need to remove the tabs from the final product. Kind of like when you're building a plastic model. You break the part off, then you may need to use your X-Acto knife or your sandpaper to smooth that one area, but nothing critical. It's all cosmetic at that point in time. So that's what I'm going to do. So in order to do this properly, though, I need to figure out where I want to locate the tabs. And you got to locate your tabs in an area where you can pretty much machine every other aspect of the model without, limiting access to different faces. So I think what I want to do is I got to look at it from the different faces. So let's look at it from this face here. Let's turn off the stock if we can. Okay, so the stock's off. Let's turn that sketch off too. Okay, so the best machinable flat face that I have that would be easily to remove and any cosmetics would not be noticed later on down the road would be on this lip here. Okay, so the lip where the motor housing and the motor cover come together, sort of like the edges of cups, because that's going to get just smooth, flat, easy to do. So what I'm going to do is, no, I can't just tab straight off of that and over. Well, I could, but I want to leave myself the ability to cut the outside contours um, with the tool coming down from this angle. So my tabs will be spaced at least, maybe a 1/16 of an inch downward before they go back to the base of the machine. And then let's turn that stock back on. Okay, so, and now to give myself as much access as possible, I'm going to have the tabs come off of, I'll probably have one come off of this side of the motor cavity, one off of this side of the motor cavity. They will extend upward away from the motor cavity. Then they may very well extend outward to the very outward edges of the stock. And then thin rails that go all the way back to the base. And if I have two tabs from opposing sides of the part, it'll actually still be held fairly strong right till the end. So let me show you how I want to do this, because that was like sort of a last minute consideration. So we're not going to even play in this model here, and we are going to open this motor housing file that I have been working on. So there's the stock I'd created, and now the only thing I don't like about this is using a much larger block of material, but the time savings, it's actually going to be much more cost effective, I think, to do it this way than to have more labor intensive second operations. Okay, so this is the block of material we have to work with. So I can leave tabs anywhere inside this block. So let's do a couple quick measurements here for fun. Let's turn off the stock. Let's measure from this face of the stock up to, or the face of the motor housing up to the stock is 14 millimeters. So I'm going to make a, what did I do with my pen? There we go. Okay. I'm going to make some quick notes over here as to 14 millimeters as that distance. So that means my tabs can be up to 14 millimeters tall. And what is the distance from this outer face to this side? Let's, oh, okay, so 4.5 millimeters. Now I know that my model is centered in my plastic, so make another note of 4.5 millimeters on my paper here. And let's see, what else do we want to consider here? Let's get, no, that's not what I want. Let's turn this off one more time. Let's see if we can go from there to the top. Okay, so that's 20.73, almost 21 millimeters. And what is the circumference of that? Again, that is a 13.075 radius plus the 27 and change. So to the center of this cavity, we have roughly 40 millimeters. That seems like a lot, but I guess it's correct. So just going to do 40 millimeters in my notes here. So that's just an approximation. That's all I need to worry about there. Okay, so we're working on this face. Let's just control save here where we're at, because that is anybody's most important tool when you're working on a computer. Okay, so we're going to look at the front face. We're going to start to draw our tabs. We are going to, let's just work on this side here. We're going to sketch on this plane, draw a rectangle, and let's say, oh, let's go, oops, that's the wrong one. Let's go 6 millimeters by 0.75 millimeters. So that's probably about as big a tab as I can get on there comfortably. Let's do a midpoint constraint from here to, nope, wrong. Okay, let's just drag it down here. And let's do, there's a shorter way to do this. I'm not familiar with it. There's my midpoint. Now we'll do a vertical horizontal constraint between this and this. And let's see. We know that the block of material is 1.5 inches wide. So let's do a dimension of this outside edge of the tab to the center point. Let's do that at 0.75 inch. And that is a vertical tab. And now let's, oops. Didn't mean to exit the sketch, but I did. Okay, so now let's do a quick line up there and select, and we're going to mirror something in our sketch. We're going to mirror this box we just created. We're going to mirror it opposite this line. So now we have opposite tabs, and okay, finish sketch. All right, so sketches off. Let's turn particular sketches off. Let's turn that off. Okay. And we said our height up to the top of our stock is 14 millimeters. So we're going to extend these two tabs we made, 14 millimeters. Done. And now we will do another sketch on this face this time. And let's do from that corner to this side, and let's do 8 millimeters this time, because that's 3/8 of an inch. It's a much healthier tab. Okay, and we'll do a little vertical line. Then we're going to mirror this sketch we made on the opposite side of here, so it puts that over onto the other tab. We'll say OK, we click Finish Sketch, and now we want to extrude this in this. Make sure we're going in the right direction, because we want to come this direction to the top of the motor housing, and I think we said about 40 millimeters, but our other tabs are 6 millimeters wide, so we can subtract 3. So off of this face, we'll go 37 millimeters. Okay, so that kind of looks weird, but oh, all right, I missed a step. All right, so those would be the tabs that we left on the stock. So then the next thing we're going to do is build. I wanted to build off of this face, up a little, then out to these. Not the end of the world. We just go backwards. So what I'm going to do here is I'm going to go back to, you know what we're going to do? We are going to go back to, all right. Sketch, extrude, Let's go from here to here. Sorry for wasting your time, but we're gonna start that all over again. What is this sketch? Okay. All right. So part of a learning curve. So okay, we're gonna sketch on this plane and kind of blow through this a little quicker now because we sort of know what we want to do. We're gonna go 0.75 millimeters by 6 millimeters. We're going to add the center point here. We're going to constrain that point with that. And let's do a quick kind of peek here to see that this rectangle is not going to touch this inner or this outer. So let's get it kind of in the middle there a little bit. And let's get that dimension from this line to this is going to be, so 13.25 is probably the best number. And let's do, all right, we're gonna do this. We're gonna mirror the features later as opposed to doing everything twice. Okay, so let's extrude this up 2 millimeters. Okay, and now let's do a quick sketch here. Quick rectangle tool over. We'll go full 1 millimeter by 6 millimeters. Perfect. Finish sketch. we're going to extrude that out to, so it's 14 from the center. And I think we can add, well, let's go 5 millimeters out. I think that's good enough. Let me view it from the front. Let me turn on the stock quick. Hey, that's a pretty good guess. All right, so turn that stock off. And next thing we're going to do is sketch on this feature. Another one. Let's go from this corner to here. Let's go a full millimeter that way. And you know what? Let's 1.5. We've got the material. Let's just use some. Finish sketch. Okay, we've already come up 2 millimeters, so we have 12 more millimeters to go up to the surface of our material. So let's bring that up 12. Then we're going to sketch again on this face, and we are going to use the same rectangle tool. We're going to go like this. I think this one we said we wanted to do, oops, excuse me, 1.5, and let's go 8 millimeters on that one. Give it a little more oomph. And I think this one here will extrude, I think we said 37. Okay, so now you can kind of see this is an elaborate tab. A tab is not usually this crazy. It's usually sort of one-dimensional, coming in from an outside, touching in a point or two locations or multiple locations on a product, preferably on different planes. It gives it more rigidity, but you can't always get that. Okay, so there is that feature. Okay, so now what we're going to do is we're going to go to modify, no, create, we're going to mirror features. We're going to mirror this extrusion, this extrusion, this extrusion, and this extrusion. We are going to use the mirror plane of that axis, that plane, and okay, so that was easy enough to do. Just mirrored those tabs over there. I'm going to go back 1 second here and just make sure that each of these was a join operation so that I'm not going to end up with any extra bodies. Okay. Okay, so there's our tab. Let's turn on our stock. All right, so I went a little excessive on here, not a problem. We'll just quickly go from this surface to this surface, find out it's 6.23, blah, blah, blah. 6.25 is what I can remove off of that. So let's go to this feature here. 37 minus 6.25 is 30.75. All right, what'd you do, Mark? Okay, let's back that out. All right. 31. That's there. Okay, do not know why that didn't want to show me the other way, so 30.75. Okay, it didn't want to show me before. Okay, so now you can see that is the very outer extent of the material block. Okay, so now I can physically come in and cut all, oops, excuse me, I can cut from this side. I can come in and I can cut everything. I can even separate the product from the clamping vise at the last second because it will be supported by these two tabs. So now, and I come from this side, you can picture this being the top now here, this surface, I can do all of this. I can surface, I can get these radiuses on here. I can get this flat on here, all with 3D machining, 3D contouring. Um, and when it's held upright like this, I can do my tapered angle, my threads, everything. There's nothing on this part that I cannot physically complete now. And then when when I'm done, it'll be held to the clamping fixture, the vise, by just these two thin rails. Now, obviously, I will keep these as thick as possible, as long as possible. But once all the heavy material needs to be removed and everything's just detailing, I can let it hang from this as I do the 3D contouring to separate the bulk out. And I will just make really thin, lighter passes to not have as much product and tool deflection going on there. Anyway, so then this will be hanging just like this from the vise when we're done, and I will be able to physically reach in there and just grab the body of the motor and give it a little twist and break those tabs off. Or I could reach in there with a pair of cutters and just sort of cut the big tabs quickly and easily. And if I wanted to be honest, I could machine these down at the very last second so they're barely holding on to almost anything. And it can vibrate, it won't make that big of a difference, and then just leave like a millimeter at the top there, holding on for structure, and then that's that, or I can machine away these points down here to the point where they're almost paper thin, and I could reach in and just break the part off, and then the only thing that would need to be machined would be just these flats, and that is, to be honest with you, it'll take you longer to put the part into a vise, hold it, and press go. And the middle will come in and go, and that's it. Those parts are flat and insanely accurate. So it's hard to even call the second operation an operation. And to be honest, if I wanted to do this, I could machine these down so close and paper thin, or I could bring them over to like a buffing wheel and just take off the edges manually by hand. But I like to do things a little more accurately than that. So this video's gotten pretty long. It was supposed to be quick and short and easy. So, but again, you have a little more insight as to how things are made, how things are manufactured, how I think about things. And while I was designing this with you guys, I have to keep all of these future processes in my mind. I have to give them consideration during the design of the product, because quite often in the manufacturing world, somebody can design and engineer, the most brilliant thing on the planet, and when it gets to the machine shop, it makes life hell for the machinists and the engineers on that end to figure out how to fixture something, how to hold something without taking 1,000 different setups and a ton of man hours and all that other fun stuff. So yeah, this is, you can kind of see how this part will be fixtured, held in the vise, how I have to go about looking at it from each angle that it needs to be machined from, and how I get to the end result. So that's that. I'm just going to call it quits here. So one more time, if you like what I'm doing here and you appreciate it, please be sure to hit the subscribe button. Hit that like button as much as you can, because that makes a big difference in the YouTube world. Even if you don't subscribe, you hit that like button. It tells YouTube you find a little value in what I do, and they will show my video to more people, and we can share this learning process with others. So the other way you can help is share these videos with your friends, start a conversation, and start a conversation with me. Put some comments below. Ask me ask me anything. To be honest with you, I will share just about anything I can if it's if it's worth sharing. So, thanks for watching. If you can't tell, I'm really excited about this new equipment and this new machinery and being able to do these things three dimensionally. So, hang on till the next one. We'll get there together.